Imagine signing a contract that says you'll go to another star system. The trip takes almost 7 years and you'll sleep through most of it. And if something breaks, we'll kill you rather than wake you up. Welcome aboard the ISV Venture Star, the most scientifically realistic starship ever smuggled into a movie about blue space elves. Today we're leaving the forests and oceans of Pandora and going where Avatar barely spends any screen time. The deep space logistics that actually makes the whole story possible. We're going to ride an interstellar vehicle from Earth to Pandora and talk all about how it refuels at a gas giant, how the shuttles work, and why the RDA literally abandons these shuttles at the end so they can cram more resources on for a return trip. First, the basic problem. Pandora is not just over there. It's a moon orbiting a large gas giant around Alpha Centauri A, 4.37 light years away. Even if you had a ship that could cruise at a serious chunk of light speed, you're still stuck with years of travel. So the RDA doesn't build a ship, go there once and come home, they built a conveyor belt. And by the time of the first Avatar film, there are roughly a dozen interstellar vehicles, or ISVs, constantly cycling between Earth and Pandora. Some are just leaving Earth orbit, and some are halfway through the void, some are breaking into Alpha Centauri, and some are loading up with unobtainium to head back home. At any given moment, you've got a diagonal line of starship streaking between the two suns, like trucks on an invisible highway. That conveyor belt is why at the end of Avatar, you can throw some of the humans off Pandora and send the Venture Star home, and then 10 years later, the RDA arrives back with an entire armada and a prefabricated city like nothing ever happened. They never stopped the conveyor belt. They just pointed it as an invasion instead of mining. So how do these ships actually work? Well, the Venture Star is about 1.6 kilometers long, but the bit you usually see in fan art, the spirally spine and the giant red radiators, is only half of the story. To leave Earth, the ship doesn't fire up its engines. Instead, it opens an absurdly large photon sail in a shallow bowl-like shape that's 16 kilometers wide, made from carbon nanotubes. Back home, in high orbit, sits one of the most terrifying pieces of infrastructure, a giant spiderweb of space lasers. Those lasers all lock onto the sail and fire a stream of photons bouncing off gently. The sheer mass of photons hitting the sail eventually starts to give it some oomph, and the spaceship starts to glide along at 1.5 Gs for 5.5 months. By the end, the Venture Star is doing around 70% of light speed, with the stars blurring and time is dilating with everybody on board. And this is why the weight is so precariously calculated, because every single additional gram means a longer journey. Once the ship is up to speed, the sail is no longer useful, so maintenance drones fold it along manicular hinge lines and stow it back into the cargo section like a giant ultra-fragile parachute. From here on out, the ship just coasts. For the next 5.8 years, it's aboard threading through interstellar space, climbing an almost invisible hill of relativity. Because from the Earth's point of view, this journey actually takes 6.75 years, but the people on board only experience around 5. It's an amazing thing that happens when you start to get closer to light speed. The interesting thing is what the ship doesn't do. It doesn't carry enough fuel to accelerate and then brake, because this would explode the mass budget. Instead, the heavy lifting to get up to speed is done by that laser array, and then the onboard antimatter engines are saved for the other end of the trip, arriving at Alpha Centauri and then leaving again. So fast forward 5 years of your life, and you've probably been woken up once or twice for medical checks, and if you're a crew member, maybe you did a short stint awake on crew rotation. Then it's back to sleep. The construction drones will then unfold the radiator panels and spin up the computers, and the captain gets the one job that actually feels like flying the starship, the braking burn. As there are no lasers waiting at Alpha Centauri, the Venture Star now has to slow down the old-fashioned way, by throwing energy and reaction mass out the back. In Avatar, the ISVs use a hybrid antimatter fusion engine. In practical terms, that means two things: giant spherical cryogenic tanks and enormous terrifying radiators. The ship carries anti-hydrogen, held in magnetic fields at near absolute zero. Mix in a little of that with ordinary hydrogen, and you get pure annihilation combustion energy, which you dump into a plasma exhaust. Then you inject more hydrogen as reaction mass to give the plume something to push on, and the exhaust coming out of the back is 1,000,000 times brighter than an arc welder. It stretches for tens of thousands of kilometers. Because that exhaust is so dangerous, the ship engines are actually on the front of the ship facing the direction of travel, while the rest of the ship dangles behind them on a long carbo nanotube truss. It's like a semi-trailer where the truck is made out of antimatter and the trailer is 400 people and a couple of hundred tons of cargo. Structurally, this is genius. Instead of building a huge heavy spine to resist compression, you build a long light cable and take tension. You angle the engines a few degrees outwards so the exhaust plume misses the rest of the ship, sacrifice a little thrust. In exchange, you keep your cryo bay and crew areas far away from those death rays on the nose. The engines will fire for another 5.5 months, again at 1.5 G, this time in reverse. The ship sheds all of that velocity and eases into the gravity well of Alpha Centauri A. When the burn ends, the giant radiator panels keep glowing dull red for weeks, dumping all of that waste heat into space. At this point, the heavy lifting is done, and a smaller fusion drive, the planetary maneuvering engine, trims the orbit and slides the ship into the Pandora system. Now, for the first time in nearly 7 years, the ship is somewhere interesting. Polyphemus is a gas giant a bit smaller than Saturn, but much denser and rich in hydrogen and helium, sitting right in the star's habitable zone. Pandora, the moon we know and love, is the fifth of at least 14 moons going around the planet. From the ground, Polyphemus is a blue-purple monster in the sky with a vast storm system that gives it its name. From RDA's perspective, it's something else, a giant, slightly radioactive fuel station. The early Avatar lore paints a really neat picture here. The ISV's antimatter engines only carry enough antimatter for that one braking burn or for one acceleration burn on the way home. They rely on a permanent orbital infrastructure around the gas giant to refuel. Think of it as a floating gas station that we never get to see on screen. Conversion rings, antimatter factories, hydrogen depots, and swarms of robotic scoop ships driving into the gas giant's upper atmosphere. Scoop ships? What did I mean by that? Well, they're built out of something you do see on screen, those shuttles. Each ISV turns up with 2 TAV-37 Valkyries docked amidship. These sleek Delta Wing shuttles you see roaring through Pandora's atmosphere, hauling AMP suits, troops, and Unobtainium back up to orbit. They're trans-atmospheric vehicles that are single-stage to orbit shuttles that can take the full payload from Pandora's surface back up into orbit and then back down again in normal service. And one of these aircraft does it in the actual film. It runs the bus route from Hell's Gate and up to the Venture Star. Cargo up, empty containers down. Scientists, security teams, avatars, and the occasional terrified paraplegic marine go up and down in a smooth rhythm, whilst the ISV loiters overhead like a freight depot. The second shuttle, though, gets a much darker job. According to the Avatar 1 era material, it's stripped out, converted into an unmanned scoop ship, and assigned to the gas giant. It dives into the gas giant's upper atmosphere using high-speed intakes and maybe even magnetic scoops to gather hydrogen, ferries that hydrogen up to orbital depots. That hydrogen becomes both reaction mass for the ISVs and raw materials for making new antimatter. And here's the brutal corporate twist. Once the shuttle goes down to Pandora with the initial landing parties and does its short-range trips, it never comes home to Earth. The ship doesn't carry the shuttle back, its mass is more valuable as refined unobtainium from the return leg. Over years and decades, every ISV that arrives adds another shuttle-turned-drone to the fuel network and leaves another shuttle down on the surface. The system slowly builds up an invisible skeleton of human hardware around the gas giant, whilst the ships themselves get leaner and more heavily loaded with ore. And let's pause on the Venture Star itself for a second and walk through the ship from nose to tail like a maintenance tour before launch. First of all, we have the twin antimatter engines and their spherical tanks. They're mounted side by side, angled slightly outwards. Between them and the rest of the ship are layers of shielding and the bases of those giant radiator wings to get rid of the excess heat. Behind that is the long tensile truss, a carbon nanotube framework that handles the pull of the thrust. Part of it is sheathed in radioactive material to protect against stray heating from the engines. Somewhere along this spine runs a pressurized tunnel that connects everything together and lets the crew and robots move between sections. Next, you hit the cargo block. Imagine 4 levels, each with 4 big cargo modules, and each module is broken down to 6 self-contained pods. An overhead robot crane slides up and down, plucking pods and loading them into the shuttle's bay. On the outbound leg, those pods are full of high-value, low-mass technology, seed factories, microelectronics, medical supplies, and avatar equipment that the things in Pandora cannot build locally. And then on the return trip back to Earth, the pods are full of dense unobtainium and any other exotic samples that the RDA thinks they can send back home, like that oil from the whale's brain. Clamped to the side of that cargo section are 2 docking rings, each with an access tunnel to get there. Those tunnels lead back to the habitation section. 3 big modules housing the cryo vaults and avatar tanks. The structure here is mostly composite and foam, minimizing metal, because when high energy cosmic rays hit metal, you get a nasty secondary radiation shower. Not ideal when you have 200 sleeping customers who paid their ticket in ice cold cash. And those customers are the passengers, because up to 200 of them per ship are stacked like cordwood in cryosleep. The crew is tiny by comparison, around 25 souls in total. 3 teams of 5 on-duty crew rotated through wake cycles, plus medical personnel mostly kept on ice until needed. At any one time, only a handful of humans are ever awake on the ship, just enough to monitor systems whilst the automation does most of the work. Life support is also an almost totally closed loop. Oxygen is stripped out of the carbon dioxide and returned to the air, taking other contaminants with it. Water comes from humidity condensers and distilling urine and waste. Dried solids become fertilizer for little hydroponic gardens that grow fresh greens and fruit to break up the monotony of freeze-dried meals. It's basically a slightly more homicidal version of The Martian stretched over 5 years. And there's one ugly line in the operations manual. The cryo systems and the passengers and cargo are only designed to wake up everybody at either the beginning or at the end, or in a very small maintenance batch. If the main passenger cryo bank failed halfway through the voyage, the life support system couldn't keep everybody alive for years. The official RDA doctrine would be the passengers be euthanized rather than risk the mission and cargo. The crew, of course, in their separate triple redundancy cryo systems, would stay alive to bring the ship home and its cargo. Behind the cryo blocks are the 2 crew rotation modules, smaller habitats perched on the ends of traverse truss. During the long cruise phase, these arms spin to give the awake crew a little centrifugal artificial gravity, enough to keep bones and muscles from dissolving completely. During burns, they fold back in line so the direction of down is aligned with the thrust vector. It's one of those simple, elegant touches that makes this ship feel more like a real engineering project than a movie prop. Finally, at the back, or the front depending on which phase of flight you're in, is the mirror shield. While the ship is leaving Earth, the shield faces backward, protecting the structure from any light that misses the photon sail. Once the sail is collapsed and stowed, the whole ship slowly flips over and the mirror shield becomes the forward face, a multi-layer Whipple shield intended to stop interstellar dust grains. At 70% of light speed, a dust grain, a fraction of a millimeter across, hits like several kilos of TNT. If you let that strike the cryobay, the voyage is over. To avoid that, the shield isn't a single plate, it's several. The first thin layer is to vaporize the grain into plasma, and the second to intercept the spray, and a third and fourth as backups. At cruise, the shield can even be detached and flown tens of thousands of kilometers in front of the ship on its own little thrusters, buying more reaction time for the ship to make tiny course corrections around anything too big to absorb. Put that all together, the engines on the nose, the long tension truss, the tiny living section, and the giant radiators, and you get something that looks weird to a movie audience, but makes aerospace engineers quietly clap. It's less sleek Star Wars cruiser and more like nuclear freight train with the death laser attached. Now, let's drop back into the films. In the first Avatar movie, we only ever see the surface effect of all of this. Jake waking up, limping through a gravity well to the shuttle and dropping into Hell's Gate, and the Venture star glinting in orbit. The logistics chain is just background, but it's always there, humming away, bringing fresh personnel and shipping refined unobtainium back home every 6 to 7 years. At the end of the film, the Na'vi win, and the humans are rounded up, marched to the shuttles, and loaded back into orbit to be sent home. It looks final, but if you zoom out, the whole conveyor belt, things get messy. There are at least 5 to 7 other ISVs still somewhere along that route. Some have already halfway to Pandora with hundreds of sleepy miners, security forces and administrators who have no idea that they're now technically invading. Some are on the way back full of cargo and completely oblivious to the uprising that just happened. The orbital depots around the gas giant are still there, attended by drones, and the antimatter factories are still churning away, building up reserves of fuel. Jake and the Na'vi will never be able to attack that infrastructure, maybe because they don't know it's there, or because they would be condemning thousands of people in cryosleep to death in interstellar space, because they wouldn't have any fuel to get home. And that sets up a brutally interesting moral dilemma for the time between the films. When the next ISV arrives, what do? Do you let them dock, refuel, and wake up the crew and turn them around quietly, essentially saying, there's nothing for you here, go home? Or do you attack the ship itself whilst it's still in the black world of deep orbit, as hinted in some of the comics? From the RDA side, the choice is much simpler. As soon as word gets back to Earth, travelling at light speed, that they lost Pandora, the boardrooms start to sharpen their knives. Any ISVs that hadn't left yet gets loaded not just with miners and scientists, but with soldiers, exosuits, and the beginnings of a proper colony. If you crunch the numbers, however, each transport only has enough capacity around 200 people, and there's no way to add more. And the incoming spacecraft are full of people already, so what happens to the 2,500 people that were kicked off the planet? We know about 500 stayed, but what about the other 1,400 that are just left to die somewhere on Pandora? By the time we reach Avatar: The Way of the Water, the ISV design has been upgraded for that new mission. The ships arriving at the start of the film aren't just freighters, they're weapons. The habitation modules have been replaced or extended with massive landing blocks, 40-story slab-sided city modules stuffed with factories, mech bays, and artillery. The ISVs have been hardened to survive actual atmospheric entry using their antimatter engines like insane retro rockets. That's the scene that we see at the opening of Way of the Water, an ISV screaming down through Pandora's sky, engines firing downward, its exhaust lighting the forest on fire. The landing module hangs underneath the skyscraper on a cable, with the exhaust plume fanning out into a 25-mile wide firestorm, literally sterilizing a landing zone as a defensive perimeter. And then, as quickly as it came, the ship cuts its thrust and hovers now just long enough to set down its sling-loaded city block, detaches and climbs back into orbit, ready to leave Pandora hanging under an artificial sun of its own making. It's the same basic hardware, it's the same photon sails and antimatter engines, radiation and shields, but by the time of the second movie, the mission has changed. It's no longer mine the planet and go home, it's burn a colony into the biosphere and stay. The quite brilliant thing about all of this is that it isn't so far beyond ideals people are playing with today. Beam sails are an active research topic. Interstellar probes like Breakthrough's Starshot are literally just tiny venture stars without the cargo and the antimatter. Antimatter is absurdly expensive, but we do already make it in tiny quantities and trap it in magnetic bottles. We've even spotted possible gas giants in the Alpha Centauri system that on paper could have habitable moons of their own. Avatar just takes all of that and skips a couple of centuries and hands it into a mining conglomerate with no meaningful ethical oversight. So the next time that you watch Jake Sully wake up on the ISV Venture Star, or see that horrifying re-entry firestorm in Way of the Water, remember the machinery in the background. There's a 16-kilometer long sail back home focusing the output of a whole power grid into a beam. There's that necklace of invisible depots around the purple blue gas giant with unmanned shuttles that are never coming home, and there are 10 to 12 starships stretched like beads on a string between the two suns. And somewhere in the fine print of every ticket to Pandora, there's a line that reads, "In the event of a critical systems failure, passengers will be humanely euthanized to preserve mission integrity. Please enjoy your flight."